What's happening? I can't see my stream. This is strange. Hey, what's going on? Oh, ah, that's a big relief. Anyway, so I started this question yesterday, and the light was messing about, so I just had to leave it and come back to it later. But yeah, so my implementation yesterday was not good, and I'm just going to remove this for now and go over the problem and try to understand exactly what the problem is asking. So, um, this is leads code 2116. Check if a parenthesis string can be valid, right? So a parenthesis string is a non-empty string consisting of an opening parenthesis and a closing parenthesis. It is valid if any of the following condition is true, right? So when it is an opening and closing parenthesis like this, so this is a pair that matches. It can be written as A concatenated with B, where A and B are valid parenthesis strings. It can be written as A inside a parenthesis where A is a valid parenthesis string. You are given a parenthesis string S and a string locked, both of length n. Locked is a binary string consisting of zeros and ones for each index I of locked. Okay, if locked I is 1, you cannot change SI. But if locked I is 0, you can change S at I to either this or that, to an opening or a closing parenthesis, right? So return true if you can make a valid parenthesis string, otherwise return false. Oh, okay. Right, so let me use my board again as usual to kind of visualize what the question is about. So I'll just go. I don't want to put it like this. So I'll just. Uh, there was a way to hang the question around, right? I would have done that, but I can still copy these questions here. I'll just copy it like this, and yeah. So just come here, remove that, and use this board like this. I'll just do Control Shift Paste, so he pastes the question for me. Right, this is not too bad, so I can see whatever the question is. I'll just put it here like this, although this is taking a lot of space. Yeah, what can I do? So let me just put this back here. Oh, okay, no way. All right, so yeah, great. So let me change this to a white. Now white is not good. Blue, green. Blue is okay. Yeah, blue is okay. And you can read. I'll leave a link to the question in the description so that um, you can have access to the question. Question 1 here will be this leads code 2 harmony. How much? 2116. So let me save that. Yeah. Then it means I don't need to have this on the screen anymore. Oh my god, I've closed it. Ah, let me just bring it back. History, restore this one, and restore this. Where is valid parenthesis here? I mean, I'm looking for check if yeah, good. Okay, so that's about it. I'll just remove this from the screen and I'll have it on my other screen and read them, right? So if you are following with this, you can access the link in the description to solve the question. All right, so a parenthesis string is a non-empty string consisting of an opening and closing brackets. Okay, so we'll have opening and closing brackets. So our string is typically going to consist mainly of opening and closing brackets. There will not be any other, so I'll put S as our string and put this in quotes so to represent a string. So the string will consist of, all right, let me do it this way. I'll call this yes, S is equal to this and that. Okay, so mainly values like this, right, with opening and closing parentheses. Now a string, this string, right, is valid if it consists of just an opening and closing bracket, right, or parentheses, or it can be written as A concatenated B, where A and B are valid parentheses. So A could be, so S is also valid when it is written as A and B, right? So A is actually a valid parenthesis, and we know that a valid parenthesis is a pair of parentheses like this, a pair of, that consists of an opening and a closing parenthesis like this, and B will also be the same. So A and B, right? This is also equal to a string like this. Let's do it this way, right? So this is also a valid parenthesis string, and the next condition is A written as A inside is a parenthesis, right? So we can have A like this, or which is also equal to a string like this, like that, right? Because this is A, this is A here, and this is our parenthesis, guarding A, which is also a valid parenthesis. So yeah, this is also a valid parenthesis. Okay, now you are given a parenthesis string S and a string locked, right? Both of length n. So locked and the string have the same length. Locked is a binary string consisting of zeros and ones for each index I of locked. So locked has its own conditions too. So if lock is 1 at index I, right, then you cannot change S. But if locked is 0, then you can change S, right? So I will bring this image here, right? This is just a visual representation of what okay, so let me bring this here. I will probably see this. So when we see um so in on this picture, right, in this image, um every time locked is equal to 0, we can swap we can swap the value or the item at S at index I, the item in X at index I, but when it's equal to 1, we can't make a swap, right? So, and this image is also saying when an item is, at this index, let's just use an example for instance. So here we have a string S and locked this value here. So I'll just put it here like this. Let me just delete these ones. I'll delete everything, bring back the image, right? I'll bring back the image here and paste the prompt. Okay, so these are our inputs here, and let's just quickly go through, right? So this, when you think about this question, right, it is kind of, you know, so it's a stack question obviously, but when you look at this, right, when I, or when we're at index 0, right, here, this is the index here. At index 0, if the value of locked is 0, it means we can make a swap. We can swap the value of the character in the string, right, at that position, at that index 0. So here's what we're going to do. We can see when the string, the character at 0 is a closing parenthesis, we make a swap, right? But when the locked value is 1, we can't swap, we just keep it like that, and this automatically creates a valid parenthesis string, right? And the next time we see another value again, so let's say we have so at index 0, if it's at index 2, sorry, the value of locked is 0, which means we can make a swap, right? But the item at that position in the string, at the position 2 in the string s, is not a closing parenthesis, so it's an opening parenthesis, so we don't need to make a swap. So we keep it like that, and then we keep going, right? We keep going, and at the next position we have another string here, right? Another item here, which is a closing parenthesis, and the value of locked is 1, and we know that our previous value was an opening parenthesis, so we just keep it like this, and this also creates another valid parenthesis string. But this time around, at this position here where the index is equal to 5, the item at that position in the string s is a closing parenthesis. So locked is basically saying, okay, so at this point here, we can make a swap. So we swap this to a different value. So we swap this to a closing parenthesis, and the next value here is also a closing parenthesis, but we don't need to close it because it's already valid, right? So we just create another valid parenthesis string here. This is so that is how the operation is going to go. But how do we really check, for these values, right? When we are going, looping through each character in the string s, we want to keep, we want to know the value of the next item as well, so that we can know if we should swap or not, right? Well, that is interesting. So here's what I'm going to do. I'll create a stack, and each time I loop through the string s, I'll stack an item in the stack, right? I'll put an item at the top of the stack, but at the same time, the item at the top of the stack has to be an opening parenthesis, right? So that I can add in a closing parenthesis, right? But in the case where we are at a position in the locked string here, and the value is 1, we can't make a swap, right? We just put the string inside regardless of whatever s at I is, we just put it on top of the stack, and then the next time we find a value that is also the same as, let's say for instance we added a closing parenthesis at that point, and the next value following it is also a closing parenthesis, then that would basically tell us that the string is not a valid parenthesis string. Yeah. So let me just demonstrate that quickly. So as I'll create a stack here, right? I'll create my stack here like this, and each time I'm looping through this string here, right? I'll always check if the topmost item in the string um is a closing parenthesis, right? If it's a closing parenthesis, it means we want to start a new pair of valid string, which means we need to swap it to, sorry, if my topmost item in the stack is like this, right, it means I want to start a new swap, right? I want to add on top of this, I want to add um what am I saying? Hold on, let me let me go back again. So let's say I have my stack here, right? This is my stack, and I'm looping through the string s, right? I'm going through the string s and adding each value. So at this point here, I want to, I always want to make sure that the topmost item in the stack is a closing parenthesis, so that I can start a new one, right? I can start a new one, and each pair, can validate the other, right? So we have, we'll have something like this. I'm just going to, sorry. So let's say this is my theory, right? So what I'm saying is every time before I stack an item onto the stack, I want to make sure that the topmost item in the stack is either uh, is going to be an opening parenthesis first, then a closing parenthesis, right? An opening and a closing. So each time, the pairs will match each other, right? So this is that. This will go with, so we can't have something like this because this is a closing parenthesis. We can't stack a closing parenthesis where there is already a closing parenthesis pair, right? I'll just call it a bracket, right? If we have a closing bracket on the at the top of the stack, then we want to stack an opening bracket. So opening, closing, opening, closing each time. But when we have a closing, right? When we have a closing bracket on top of the string, we can't, we need to swap the value of the next one to always match this one. Otherwise, we'll have something like this, and these two are not valid, right? This closing bracket and this closing bracket will not be valid. And before we even make a swap, we also need to check the value in the locked string here, because this locked string has to indicate whether we can swap or not. If we can't swap, then we can't add any other item in the string. So here's what I'm going to do. So this is an example. So I'll just use a different color to stack the items. So I'll add the first item, right? I'll look at the first item and look at the value here, right? The value here is 0, and then at the top of our stack there is no other value, so it means I can swap, right? I can make a swap. So I'll swap this to an opening parenthesis, right? Then we are at position 2 or index 1, right? So index 1 here. Here we also look at the value of this this is 1, right? There's no need to look at the top of the to look which item is at the top of the stack, because 1 means we can't make a swap, so we just directly add this to the stack here, right? This is it. So this already forms a valid parenthesis string. Then we go again, right? We add a new, we at position 3 or index 2, position 2 or position 3 or index 2, right? So at index 2, right, the value of the parenthesis is an opening parenthesis, and the value of locked at this position is 0. It means we can make a swap. But we can also look into at the top of the stack and see if the topmost item in the stack is an opening parenthesis, right? But at this point it's not an opening parenthesis, right? So we just directly stack it on top, right? We don't make a swap, we just keep it like that. And then we move to the next part here. So we are at this point here, right? So at this point, the string is a closing parenthesis, and the value of locked is 1. So we don't even need to check whether we should swap or not. So we stack this on top again. So we created another valid pair. And then we are at this point now at position, what position? This is 0, 1, 2, 3, 4. So we are at position 4 here, right? This is a closing parenthesis, right? This is closing. So we also need to check in our log string, when we see that the log string has a value of 0 or a binary value of 0, then we can consider swapping, right? But before we swap, we also need to check the topmost item in the stack. So the topmost item in the stack is a closing parenthesis, right? It's a closing parenthesis, meaning it is matching, a previous opening parenthesis. So we need to swap at this point. So we swap it to something like this, right? And then we move to the next item here, right? The value is also 0, but the topmost item in the stack is an opening parenthesis, which means we don't need to close it, right? We just put it like this and we add it on top of the stack. And yeah, so that is it. And we are at the end of our string. We did not encounter any situation where the previous value was equal to it was impossible to make a swap or a stack, right? So yeah, it means it is a valid parenthesis, right? Now, um let's look at a situation where the string is not a valid parenthesis, right? um Now this alone doesn't what is the only situation where, so our stack must have um our stack must have an even number of length, right? So we can't have, so let me use a situation where the string might not be valid. So I'll just remove this, right? Let me just remove that, and let me also remove this from here. Okay, and let's say the string s is something like this. I'll just create something random and just make sure that it's not a valid string. So I'll have something like this, another one like this, and another one like this, right? And then locked has to have the same length as the string s. So I can have a value like this. I'll just say um I can say um so 0, 1, right, and 1. Let me just do it this way: 0, 1, 1. So when I'm going through the stack, right, when I'm going through the string, I'll stack it, each item in the stack. So I'll add this first. I'll look at this, the first item in this locked, right? It's 0. Is there any item on the string in our stack before I can decide to make a swap or not? So there's no item, so I can add it to the stack, right? Because it's it's an opening string. So here I'll add it to the stack, and then the next item we have is a 1, so we can't add 1 on top of our stack. And the next item we have is also 1, and this at this point here is an opening stack, right? opening string, right? Opening parenthesis. So we can just add it to the stack. But when you look at this, right, there is this other one missing to match this to make it a valid parenthesis. So because the length of our stack now is 3, right? This means there is, this is invalid, right? This is not valid. This can be valid because the third item in the stack has to have a closing pair, right? And the closing pair has to match it as well. If we had another value here, I'll just let me change this to a C and then this to another C here like this. Oh, let me add it like this, right? Now we have 4 items in the stack, right? But this time around there's something interesting happening, right? So here I'll also add a 1 here, right? Now we can look on top of this at the top of this stack we have a closing parenthesis, and the value here is 1, right? We can't have the same pair of parentheses following each other automatically, even though the length of this is 1. I mean the length of this is 4, right? Which means every item has a pair, but in the stack, right, we can't add the same item on top of each other. We need to differentiate them every time, right? So this means that the topmost item on the stack has to be a closing pair, and the the um the last item in the stack has to be an opening parenthesis, and these are the conditions that makes it a valid parenthesis string. So I'll go ahead and code this, and yeah, so let's try it out. um mm, mm, this and that. So we have, so here's my implementation yesterday, which was absolutely wrong. I wasn't even thinking straight. I just went ahead and did this, which was, you know, not good. So the first thing we want to do is to create our own stack. At the end of the day, that's what we're going to return, right? So um yeah, I'll just call this a stack of what? Stack of uh I'll I'll call it valid 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 pair stack, right? Valid pair stack. Sorry, valid pair stack like this. And I'll set it to an empty array. So this is our stack, right? And I'll loop through each item in the string s while I'm also comparing it um to the binary value in the locked string here. So let's create our loop. So I'll create a for loop for I in the range. We want to use range because we need the indexes, right? So range of the length of the string, right? So length of string s, because locked and string s will always have the same length, so we can use that. All right, so that's it for our loop, and every time we loop through the string we want to add an item to our stack. Now first of all we need to know the topmost item in the stack, right? But before we even know which item is at the top of the stack, we need to find out um which which um which item is first, right? If whether the stack has a value or not, right? We need to do that. So if I say if not stack, right? If not stack, sorry, if not stack, right? Sorry, I called it valid per stack. If not valid per stack, right? Then we want to add an item to the stack. So we add if not valid per stack. Before we add an item, we also need to know the value of our locked string here. right? If not valid per stack, right, we know there is no item, so now we want to push an item to the stack, but we need to push it based on a certain condition, right? So item if not valid per stack, and and the item at, you know what, let me not do it this way. If not valid per stack, if the stack is empty, then we can copy and do this. If if item at the first if locked at I, right, if locked at I is equal to 0, right, is equal to 0, yeah, it's an integer. So if locked at I is equal to 0, and the item at the valid pair, I mean the string here is an opening, is a closing parenthesis. So here's what I'm saying. If I'm at this point, right, before I add any item to our stack, I need to know what this value says here. If this is 0, it means we can swap the value to a closing parenthesis. I mean to an opening parenthesis. This right now is a closing parenthesis. Let me just highlight it quickly. This item at this point here is a closing parenthesis. This is a closing parenthesis. But if the item here, right, is 0, and the value of our how do you call it, if this is 0 and this is a closing pair, and we don't have any item in our stack, let's say our stack is empty at the beginning, it means we want to add a closing parenthesis to the stack. We can't just add the opening parenthesis. This says we can swap, right? We can swap, or we just keep it like that. But we know we can't just keep it like that. We need to swap it when the stack is empty. And the value at si, right, is equal to, I'll just do it this way, is equal to a closing parenthesis, right? We need to add an opening parenthesis to the stack. So I'll just say valid per stack dot append, append an opening to it. Sorry, append an opening to it. So here we've appended the opening, but in the case where the value of this is 1, then we don't need to make a swap, right? Regardless of what it is, we just append it to this thing. So if locked at I is equal to 1, then we don't swap, we just append. So valid here dot append the item at si. So just append the item at si. Yeah, so that's it for when the stack is empty, right? But in the case where the stack is not empty, we want to know certain things. So else, now the stack is no longer empty, right? We need to check which item is at the top of the stack. So let's just take this. So if valid per stack, so we want to get the topmost item -1, right? Yeah, sorry, the length -1, length of the s, no, want to get the last item in the stack, right? We can use -1. This will still work. This will give us the last item in any array. So let's just quickly check that. I don't know why I keep forgetting things like this. So print stack, right, -1. This will give us 6. This should give us 6. Yeah, so this is 6. So that is our topmost item in the stack. So I'll just use that. And I want to get that value, and I want to make sure that it is an opening tag. So here's what I'm going to, an opening parenthesis, right? So if this is equal to right, is equal to an opening parenthesis, right? And sorry, and the value of our locked, so value, sorry, locked, locked is if locked is equal to 1, right, it means we don't need to make a swap. If locked is equal to 1, we don't need to make a swap. And we also need to know, hold on, we need to know whether the item in this string, right, is an opening parenthesis, right? If it's an opening parenthesis, okay, yeah, we this is quite straightforward. If this and s at I, right, is equal to an opening parenthesis, right, or a closing parenthesis, sorry, a closing parenthesis, right, then we don't even need to check whether s is asking us to close it or not, right? We already do that is at the top of our stack and we need to add the item. That's cool, right? So we just do stack valid pair stack dot append item at s, so s at I here. But in the case where the value here um is not 1, right, the value here is not 1, it's not a closing parenthesis, sorry, else if, sorry, elif um valid pair stack yeah, is still the last item, the item at the top of the stack is still equal to an opening parenthesis and the last item in the stack, right, last item in the stack is not is a closing, is an opening parenthesis too, right? and and the value of this locked string here, so I'll just put locked. I'm just trying to do this as logical as possible. So yeah, let's say at um locked at I, right, locked at I, if locked at I is equal to 0, right, is equal to 0, then it means we want to I think I'm just adding a lot of conditions here. If the valid pair is this, right, if it's like this, if the topmost item in the stack is an opening bracket and the next item in the string, right, is also an opening bracket and the locked at I is a 0, right, it means we just want to append so valid pair stack, right, we want to append yeah, we just want to append the closing string. This will transform the item here, right, this will transform it to a closing parenthesis, so it means we are swapping this value. We can create a variable that stores the value of si and then we swap it inside that variable, but just the same as doing it this way, right? So here's what so we've done this, we've added this closing pair to the stack. Now this is when everything is good, but in the case where else if valid pair stack, right, valid pair stack has an opening parenthesis already, right, valid pair stack at the top of the stack, has an opening parenthesis. Wait, I'm just doing this way and it doesn't make sense. So I mean, I also want to add. Oh, okay. This is good. This is good. right? This is good. If the valid this valid value here, valid the top of the stack here, if this at top of the stack, and we also want to stack another one because the condition here is not zero, right? um Let me just do it this way. Just copy this. Oh, those are two ends. So, and this, and the value here is is 1. It means we can't swap, right? We can't swap this value. Then we can just return false here. Return false. Sorry, return false. There's no need to stack. We just end it here. But you know, this is where everything goes wrong. And at the end of the day, when this loop runs, so here the stack is empty and we are adding a value. But when the stack is not empty, we want to add. So if the topmost item in the stack is this and that and that, well, what if the top of the stack is, a closing parenthesis, right? Then we want to stack another item on top of it, right? Well, I can say, these are all the conditions we have so far. I'll just add this as the, yeah, so else, which means let me just use another else if nah else if it's a closing parenthesis, right? Here we have an opening parenthesis, another opening parenthesis. Let me see, my stream is going on. All right. So here it's saying if the last item in the stack is an opening parenthesis and the next item we see is a closing parenthesis, don't even bother checking if the value of this is 0 or 1. Just add it to the stack. Good. This is okay. But if the last item in the stack is this, right, or the topmost item in the stack is this, and the current item is this one here, right, and the value of locked is 0, it means we can swap, right? We can swap it to this, and then we add this to this. Okay, well, in this situation where we added this, that means the value at the top of the stack is an opening parenthesis, right? So when it's an opening parenthesis that's at the top of the stack, then we can yeah, we need to check for that as well, because here we're also saying if we have an opening parenthesis already, right, and the value here is also an opening parenthesis, and we want to add this item to the stack, this will not work, right? This won't work. I'll come back to this. I think there's an error here. So else if the valid pair stack, right, negative, the top item is equal to a closing parenthesis, right, and you know and the incoming item, right, s at I is also a closing parenthesis, and locked at I is equal to 1, right? We can also return false here. Because we can't stack a closing on top of a closing, right? So we just return false. else if right, the top of the stack we have this. I'll just take this here, and now this time around the locked is 0, right? Locked is 0. Then we want to add that item, the opposite of it, right? Want to add the opposite to the stack, so valid pair stack dot append an opening here, right? So all of these conditions are met, and now we this here, right? I'm saying if the locked is 0 and the current item we have is this, we want to append this. Else if it is, it's not if, it's else if it's not if it's equal to 1, right? If locked is equal to 1, then we just add it to the stack, right? So here this is okay. So if we even if we added an opening to the stack, right, and we check these conditions here, I mean this closing here, if we check these conditions and this is equal to 1, we can't start a string with a valid, I mean with a closing pair, right, with a closing parenthesis. That is not possible. So if this is like this, right, and there's a ice this one here, I just want to make sure that we don't have a closing parenthesis, you know, as the first item we add to our stack. So hold on. Right. So although we have like a lot of conditions here, it's just, you know, a brute force solution for now. We can later look at how to improve this. But here, so this will we're just looking at the different conditions here. And in the case where the first item at this point here, if it's a closing parenthesis, right, and the value of locked is 1, right, then that means we can't swap the value. Yeah. So let's do it this way. Else, this is else, right? Else, just add the item. But I would also say else if, right? Else if the value at um here locked is 1, right? Locked is 1, locked is 1, and this, I'll just copy this. If the value at locked is 1 and we have this, right, there's no way we can, you know, swap. So we just stop this and just return false. So I'll just return false like this. Sorry. So here's what I meant by this condition here. So let me go to my board again. So when we start a string with a closing parenthesis like this one here, and the value of I here, of locked here, is 1. Let's assume that this was 1, right? This was 1. Well, in this case, it means we can't swap this value to a closing parenthesis, and there's no way we can stack any item on top of this to create a valid parenthesis. This is already a closing parenthesis, and you can't have an opening parenthesis after a closing parenthesis. So this is invalid, and we just stop, you know, looking further into the string. Then we can just return false, right? So I'll just do that like that. So here we have this and that. So we are looking at every possible solution. This else here means, well, I don't even need to have this if here. So what I'm going to do, I'll just add here if locked I is this. Okay, it means swap, right? Else, if we have a closing parenthesis, we don't need to even look at these values here. We just add it to the stack. And then when we have an item in the stack now, we need to check if this is a closing parenthesis, right? If this is a closing parenthesis, then we add it to the stack. Otherwise, if it is not, then we just say, okay, valid pair stack, right, has this at the top of the stack, and then the next value is this. So it means we can swap this to create a valid pair stack. So a valid parenthesis. I don't know why. So we can add this to the stack again, and then the next, I mean, in the case where we have this at the top of the stack again, so this is the same thing. Then, and the value is, 1, right? The value of locked is 1. It means we can't swap this. In that case, we don't want to have an opening on top of an opening. This is wrong, right? We just return false. Otherwise, another condition where we want to return false is this, right? So we have a closing on top of a closing, we can return false. But in the case where we have a closing and another closing, right? A closing at the top of the stack and another closing in the string S, right? And our value is, our value is a closing stack, a closing parenthesis, then I can just add this to the stack. But what if we have a closing parenthesis, right, and already we have an opening, right? If we have an opening, that means we don't need to check the value of I, whether it's 0 or not, right? Yeah, this is okay. So else I'll just put else, because at this point we can just do valid pair stack. We've already checked all the conditions here. So in the case where this is a closing, right, and the next value is an opening, and the value of locked is equal to 0, then we can just add this to the stack, like append s at I, right? Is this okay? We are checking for every possible solution here. So these and that for opening parenthesis, right? I mean closing parentheses here. So this is good. I think somebody is asking me a question. Let me finish and attend to the person. Okay, tomorrow is my university exam. What can I? Okay, so it's asking for preparation. Honestly, I can't really tell, but I think it's just like solve more questions and just solve, at least get comfortable with the medium questions. As you can see, I'm also learning, so I don't have an exam to prepare for. I'm just documenting my study journey here. So yeah, Just solve questions. That's the best way to prepare. Um, so this is a swap, so we can swap it to this. Now, at the end of the day, if we have like a closing, like like our opening pair at the top of our stack, or our stack's length is not even, then um it means that this is not a valid pair. So if so I'm just done with my loop, so I'll say return true, right? Return true if, okay, let me start with return first. Return false if valid stack dot length, sorry, length of the valid stack is not, if not length of valid stack, valid per stack, if it's not um right, like this divided by 2 is equal to 0, else return true, right? Return true. Also, I can say if this is not equal to 0, or at the top of the stack we have an opening, so valid per stack. This is quite verbose, but yeah, let's see if this is going to work first, right? Valid per stack, the top of the stack we have at the top of the stack we have like this, we have something like this. Then this means these are the conditions for, you know, for a non-valid pair. So I'll go ahead and run this. Let me test it out here first of all. I'll create a solution. So solution is equal to solution, right? Yeah, solution. Let me create an instance of my solution, and I just print solution dot can be valid. I'll use this first one, this first condition here, right? Okay, let's run this and see. Hold on, we are missing something here. Oh, the locked value of the locked. Sorry. Yeah. Yes, this is okay now. So moment of true. Yeah, this is true. It is a valid. You know, I'll just go ahead and duplicate this. I think if we pass the first case, the second test case is what is this one here. I'll just go ahead and put it here like this, and then the locked value here too is 0, 0, 4 zeros. I'll just put it here like that. This should return true as well. This is also true. Okay, we're passing the test cases. This is exciting. It's quite exciting, honestly. Yeah, so this should give us false. And a return false. Okay, I think that's about it. Let me just go ahead and run this in LeetCode. So I'll just bring back LeetCode here. Although it's not being formatted, but yeah, these are like different if else conditions. Let's see what it does. This should pass all the test cases. Yeah, it passed all the test cases, but there is one catch to this. You see, this, well, I don't think there's any issue, but let's run it and see. Moment of truth, and it's the wrong answer. Wow. Okay, I think I know why this is giving us a wrong answer. It's funny, right? Because now I was only checking for conditions where this and that. But if you look at this place very well, I said if locked is this, right? You know what? Let me just go ahead and try this out in my own editor here. That shouldn't have worked, but yes, it did. Okay, so in the case where these are all valid parentheses, right? These are all valid parentheses. Was I accounting for these where the values could be, all zeros? This should have given us this would have given us true, right? If we print our stack at the end of the day, you see where the issue is. So let me print the stack again. Uh, Hold on. Print valid best stack. This is not printing our stack. Why is that? Okay, so I'm checking the situation where the value of um you see this is I and here, right? Well, there was just one thing missing. I think if I add another if condition, because I mean here it's an opening parenthesis and this is one, right? But I'm only checking for you know closing parenthesis in my conditions here. So if the item at this here, right? The item at S, so I'll just put S at I is equal to what? Is equal to an opening and and oh, we have a problem. This will still return false. Oh my god. And locked. Nah, this is not going to work. This is not going to work at all. This is not going to work. Right? Even if I did it this way, it won't work. So, okay. Even if I did it this way, this is not going to work. Um, I think here's the nah. Valid best tag dot. You know what? I think I found the missing piece. So let's just add this to the stack first. Stack dot append the value at si, right? Si, because I'm also checking here if locked is 0 and yeah, so else here just append it. If it's none of these situations here, just append the item to the stack. I want to see what's in the stack. Why is this not working? um Show me. Show me what's in the stack. God. Um what was I? Okay, I'll print it here. Print the stack. No way. Why am I not seeing it? Hey, somebody from James Consulting. Yeah, I actually worked at James Consulting before. Yeah. Uh, hello, Ibuka. Nice. Um, so there is an issue with this. This is just wrong. And for this here, range length of S. You know what? Let me just do it this way first and see. Yeah, so this is my stack, right? This is correct. You can see the parentheses are properly created like this in the stack. So in this case here, I know. So if this is not, if there's no item in the stack, then we want to add an item to the stack, right? Valid pair stack. If this is an opening, yeah. Locked I is 1. Should I create a map? And instead of just manually checking this condition, I can look into my map and just get rid of all of these things. Because now this is said, okay, so there's no item in the stack, right? If there's no item in the stack, then add an item to the stack. But we are looking at these conditions here. If locked at I is 1, I here will be 0, right? So it starts from 0, then it goes to 1 and 2. So at this point here, I here will be 0, right? So special edition. I knew something was going to catch me up. Okay, if we have the first item in the stack as this, right, and every subsequent value is 1, then we want to append to the stack, right? So why is this? Okay, else if this is the, I mean, in the cases where this is 1, right, I know why this is not working, and it is sad that I know. Let me just come here. I think there's something wrong with the way I was thinking about it. If I'm able to solve this question, I'll be very happy with myself. Let me use the condition here. This is 1 1 1 1 1 1 1 1 1. Da 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 da. Black 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 sheep. Yes sir, yes sir. Okay, so here we go. We have this here. Now I usually represent my stack in this form as a bucket, so this kind of helps me to visualize what I'm doing properly. Alright, so here's my stack, and I am at this point, right? My condition was saying if I had, okay, so if my value is like this, right, we always want to have a closing, an opening parenthesis at the start of the stack. So wait, why is this valid in the first place? Because the one following it is not. Oh, I see. So this parenthesis here is closing this. This is closing that, and this here is closing this. Oh. Okay. Oh my god. And I'm already saying here that it should return false. It should return false if we have this at the top of the stack, right? Oh, okay. That's okay. That's okay. We can have a closing parenthesis at the top of stack. But what's going on now? Let me see. Let me see. This this can't be possible. Hold on. If if the locked is 0, locked is 1, and we have this right append to the stack. If s at I is else if s at I is an opening parenthesis, like in this case here, right? If it's an opening parenthesis and s, just add it to it, right? If it is an opening parenthesis and oh, I think this is where the issue is. So I'm saying if we have an opening parenthesis, right, and s at I is this, yes, and this is 1, then oh, okay, okay, yeah. In this case, this will. I mean, it shouldn't be like this, right? It shouldn't be like this, cause at the end of the day, you might have. Okay, so here's what's going to happen. If I have this and this, so this here shouldn't, honestly. I'll say valid per stack dot append s at I here like this, right? Let's do it this way. This is true. This is okay. This is true. But then this might not be true. This is still false. What's causing this issue? I think s at I is 1 here. At least it should add the first item to the stack, right? I've been just do that first. At least that I should have at least 1 item in the stack, but it's just going straight to this point here. Okay, I think it's returning false here. Well, s at I here is not a closing parenthesis, it's an opening parenthesis. So why is this returning false? At least it should just do it here, right? You know what? This is what I'm going to do. I just want to verify if this was actually working. So I'll print the valid per the stack here, valid per stack like this. Okay, so at first we were adding the items until, okay, you can see where everything started going wrong. So at first we had this, then we added this, we added that, we added this, we then added, closed, but we didn't get to the point where, oh, I see. So we're not adding another closing. So I mean, if I know we're at this point now, we are at the end here, and already we have a closing parenthesis here. I might just need to add another condition for that. Um, so here's what I'm saying, right? This is where the code is failing at this point here. If you have, or if I already had, a closing parenthesis at the top of my stack, then I don't want to add another closing parenthesis here, which is wrong, right? I want to do it. I don't need to valid per stack, right? Sorry, the append. Oh god, the append. Want to append I, right? Want to append this. This will return true, but I don't know how false it is for the other conditions, right? This should return true. Yeah, this worked. It worked here, but hmm, it worked, right? It worked, but let me see if if it will work for this one too, because that is also true. But I don't know how. Okay, it also worked for it, right? Let's test this out on Let's Code and see what. So this is the only part I corrected. At least, oh, I'm not returning false anywhere. Interesting. Well, let me just remove that. Blah 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 sheep. Yes, I yes. Ding 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 ding. Okay, 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 okay. This is interesting. I think all these force here. Here we have this and that. We need to stack it on top by force. So I'll just correct it here myself. I'll just do valid pair stack like this. Yeah, valid pair stack and dot append. Regardless of what it is, we'll just want to append, right? Append s at I. Is that what I did? Is that what I did here? So let me just close this. I'll say valid pair here, s at I, and then s at I following it. Okay, okay, and then here too, want to do s at I. Yeah. All right. Let's see if this situation will favor us. And I don't think so. Oh, it did. It did. Okay. Yeah, it will, right, for the test cases. As that was quite valid. But yeah, let's see what our submission says. What the hell? Okay. Wow. I knew it. I knew it. I knew this was going to happen, right? This is valid. This should have returned true, but it says it's false. Why do we have this at the top of our stack? Why? Why? Let me just print this out. I know, I know. I mean, is there an editorial for this? There isn't. Mm. So out of 78,000 submission, it was just 31%. Let me see the discussion. This should be marked as hard. Why are late code example always so okay? That was no. Mm. If S size is odd, return false. I mean, I said it here, right? If it's just return false. If it's not, or if at the top of our stack we have this, but we we might never have this at the top of our stack. We will never have this. So I mean, this shouldn't be an issue, right? Okay, Zoe says, is it possible at all to solve this problem if you haven't seen the solution before? I would not call this problem algorithmic. You either know the answer or you don't. Well, I think that is not entirely wrong, and at the same time, it is possible to solve it. I mean, I don't want to say solutions, but like when we look at this question very well, it is quite straightforward. And already, I've made two submissions, and they were not accepted. I think the conditions. I mean, I think the conditions I'm checking for each one of these cases are just not correct, because I'm also confused at some point here. So I'll take the pain and go through like this extremely long case. So this was 234 out of 58 cases, right? So it is quite close to like, you know, to like a valid solution. Yeah, so I'll just let me comment this out again and print. Okay, I'm not in view. So I'll go over it again and I'll just try it out again. So solution dot can be valid, right? And the first condition is this, which is extremely long. Oh my god. This is does anyone know how to format this thing? I don't know. Line break, right? Um let me just go to here. Line breaks. What's that? PyCharm. To speak very to multiple lines. Yeah, that thing is just annoying. It's really annoying. So who has a solution? Oh no. Are you kidding me? So go to code style wrapping. Alright, let me just come here. I'll come to this place. Where is it safe? First code. Where's code style? Code style. There is no way. Settings, right? I mean, my. You know what? I was just looking at the wrong place. So coding style. Command Control Alt L. Control Alt L. Did this? Nah, this is not it. This is still overflowing. You know what? Let me not waste my time on that. I'll just look for it later on. It's okay. So we go to file. Um, uh, go to settings, right? File. Okay, file. File. Where's file properties? This file properties. File encoding. Blah blah blah. Want settings. Mm. Why is this so difficult to see? File. Yes. Action. Right. Include disable dash all. You know what? That's not it. That's not what I want. I want settings. editor. Where's editor here? All right, let me not waste my time on this. This is out of the question. Um, and at the same time, I just don't want this to be difficult to look at, given the fact that I just have to reduce the zoom size of my screen in order for you guys to see what I'm doing. Well, yeah, let me just keep it zoomed in. And I don't know if this will like kind of heat up my PC, but yeah. Okay, I put this in the wrong place. So we have valid. Okay, yeah, here this is one. This should be another one, and this should be another one. So this is correct now, and this is false. It's supposed to be true. Why is it so? Right? Why is it so? I definitely won't go through all of this, but I just want to see why it is false and what condition is making it so. It's definitely it definitely didn't reach this point, right? Print um valid stack. It did not reach this point here. So oh, it did. Right, it did. So if you look this very well, look this closely, right? So you can see we are creating a valid pair. We are creating this is valid all the way. Okay. Now we have a closing and an opening here. This is what the issue is. I see what happened. I see what happened. It's because I'm saying if we have like at the top of our stack, if we have this, then which is true, right? Because we can't wait. The first one says don't change, and this says change. Okay, but we had a closing at the end. This doesn't make sense. If I removed this from here, that means I'm just kind of breaking my own logic, which is weird to like disobey myself. um, so if I run this now, this will return true. This will be valid. But like I this shouldn't have worked. It shouldn't have worked. There is no way this is possible. I mean, a valid pair, right? If I these are the two strings I have at the end, and we have this. If I'm adding this to the stack, okay, so here this should be 0. This is 1. This is another side. So if I'm adding this should have been 1. Oh God, disgusting, disgusting. this is this is not this doesn't make any sense at all. I mean, all of these are true, right? I was saying it, I even highlighted it here, right? I even highlighted it that this could be the reason why it wasn't running. But I mean, it's kind of it makes sense, right? To have like the topmost item in your stack to be, an opening parenthesis, a closing parenthesis instead of an opening parenthesis. Yeah. So let me submit this again. I don't like that this works. Right. You see, this did not work at all. It failed at this point here. Ah, this is horrible. It's a nightmare. It's not even nice to watch. What is Let's Go telling me? All right, let me clear my shame and have a look at the solutions that people provided. Hmm. Nobody solved in Python. Oh, we did left to right. What's that? Counting braces. Brackets. Okay, counting brackets. Greedy 2 pass. All these are algorithms that I don't even know of. This has 2 votes, 3 votes. Oh, claiming to be 99% right. Let's see what this guy did. Oh, let's see what this person did. Sorry. Scripts. I'll just increase my time to like another 25 minutes before I close. Honestly, I was going to. I was. Oh, God. I just saw what he did and I'm in awe. I am so disappointed of myself. So here he has two stack, right? And can change, right? So it means so here's what it's doing. It didn't even explain. It didn't even explain, but I'll go ahead and explain. So if the item is I mean if locked is equal to 0, right? If locked is equal to 0, then we want to add lock to our can change stack. Otherwise, if it is 1, we want to keep it that way. Great, great. Now, else if stack, right? So when we append an item, right? When we append an item an opening stack, an opening parenthesis, right? If the stack is not empty, right? We want to remove that item after adding it. If there is also can change, we also want to remove it. Okay, I don't get it. Let me go back again. So we are adding s at I to the stack, s at b to the stack. If stack after adding, so if it's 1, right? If the value of I is 1 and s I is 1, just add it to the stack. Okay, we want to add all opening parentheses to the stack in this case here, but if it's not an opening parenthesis, right, we want to remove them from the stack. Okay, and can change to want to remove. Let me see. I have quite a number of people here. Okay. Oh. If locked is equal to 0. I think I shouldn't really care about, what the value of. I don't understand this. I don't get this, but I know I can solve this question. I have a feeling I can. I have a feeling I can actually solve this question. I can feel it. I can feel this that I can solve the question. Honestly, okay, so here we're almost close. Like it's almost done. 234 cases passed out of 258. So it means the solution is quite correct, but not fully correct. So here's what I'm going to do. I'm just going to go back again and really. The test cases don't even make sense, right? I mean, here are the simple test cases we have been given. A valid parenthesis, right, is anything like this, right? Is anything like that. And uh, I am I am in pain. Okay, this did work, but we don't want something like. Wait. Why did this? Why was this even removed? Right. If I look at this again, see we start from here, right? This and that are okay. We did not even need to do any change at this point. You know what? I know what to do. Do I even know what to do? um, it's the condition at which the stack. Sure. Mm, 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 mm. Valid parentheses. Wait, what does this say? This condition I filled here. This is true. Right, let's check my submissions. This is expected false. Okay, why would this be false? This makes up for this. I mean, here we have 0, 0. This can change to this. First of all, what's the length of this, right? I mean, it doesn't really matter because now, at the end of the day, we search for the length. So in this case, we failed here. I failed here. I failed at this point here. Hold on. Oh my god, my phone is off. Jesus. Jesus. Ah. Oh. Oh. Ah. There is no way. There is no way. There is no way I will believe that this question is not. It's okay. Somebody say, what do you think are the important math topics for learning DSA? Honestly, for learning DSA, the important math topics, I think you being able to solve any math questions is kind of close to DSA in a way that it all comes back to like problem solving, right? You are able to identify patterns and so on. So I won't say for sure there is a specific math question to know. I mean math topic to know, but it's quite important to be able to just reason, right? And because you already know maths and you've been doing like a lot of reasoning, solving questions, like it kind of becomes second nature. Yeah, and you're able to solve these questions. But yeah, there's I don't know for now. Maybe sometime in the future. I'm not an expert in DSA myself. I'm just learning and I'm documenting my learning journey here as well. So yeah, just solve as many questions as you can and try to think of the problem logically, breaking down into pieces. I'm saying it's yeah, it works, right? But I mean, you see, cases like this are just extreme. Are just like over the top. I didn't even think of this much, but my code should have accounted for this, right? And when you look at something like this, let me just come here. Where's my code editor? When you look at something like this case here, it's quite long, but let's just look at this again one more time. This is closing that. So the only case where this did not work was here. But what are the last? This should have changed, right? I mean, if I'm saying the last item in the stack is an opening, right? If it's like this, they return false. But in this case, it's supposed to return true, but I'm returning false. Why did this not work? So in the case where, so I need to go and verify the condition where I'm adding a closing parenthesis and the value is 1, right? So what am I saying here? When you have closing parenthesis and the value is 1. So we have closing parenthesis, opening parenthesis, value 1. So these are the logs, value 1, closing parenthesis. So I'm not even accounting for that in this case here. Well, I am, but this is what is making it to fail, right? I mean, I'm saying if at the top of the stack I have this, Yeah, I have this at the top of the stack. Okay. Honestly, this shouldn't be the case. I shouldn't be doing stuff like this, right? But I just want to know what truly works. This is even valid. Honestly, this should have returned false correctly. This is not a valid parenthesis. I mean, there's no way you can reverse. Oh, I see. So here we have this and that. Wait, are they is this question saying, yeah? Is this question saying that? There's some documents for. I'm just going to do something quickly. So yeah. Mm, yeah, you're welcome. Okay, so I can see something happening here. Is this question saying that we should just have any? This is annoying. You can see here. Okay, even even okay. So in this case like this, let's just go to. You see, this matches this. This matches that. That's a valid parenthesis. This matches also this and this works. This and that works. This and this that that, and then we have an issue here, right? We have an issue here. Okay, let me. I'm just going to think about the other guy. So he has two stacks. Why am I saying a guy? I don't know who the person is, but yeah, the other person's solution. In the case where you can have two stacks, add the items in one stack, and the ones that can be reversed in another stack. I'll just look at the solution here. So you know what? I just look at one person's solution. Let me look at another person's solution again. Check if parentheses can be valid to. And this one, let me see. Come on. So def check, right? Check. So check. It's open. No write ups. It works. Check it up. It. What is it and open? What's open for? Already, yeah, we know if the length of the the string is not. That means we have three items that are not okay. So yeah, we can do this. Length return false. Right, return false. Return. Okay, I'll just do it in my code editor here. Yeah, this is true. I wouldn't wait to the end before I do that. I'll just return false, right? Before anything, if the length of the string s is not s, right? Not uh okay, if the string s is not divisible by 2, so divisible by 2 divided by 2 is equal to 0, then return false. Return false, right? Return false. I'll just put if not like this, right? Return false. This is supposedly true. And what makes it true, really? What makes it true? So here we already checked that. Now, what's this? What's the CNT? Is it a count? It's nobody's writing. So here, and I might. So we have C, min, and max. In zip will create like a closing pair of tuple. I think that's what zip does. Um so s and locked, right? So C min minus 1 if C min and J or I. Wow, this is interesting. C min. So we are reducing C min every time, right? If C min, so if J is 0, right, J will be the first item in the second one. So this will create a tuple, right? If J is equal to 0 or I is equal to a closing parenthesis, else so these are the possible ones we can swap, right? If J is equal to 0, I kind of get what he's trying to do. So you have 0 here. I don't get it. Okay, let me see. Not to sell. C mass is referring to the number of potentially or locked open parentheses. Potentially locked open parentheses. And C min is referring to the number of potentially locked potentially unlocked close parentheses. I don't. Both solutions I'm looking at. What? 100%? This is a joke. Oh, with explanation. Wow. Okay. That is good. So what is it saying? We can check parentheses are valid in O of n time by making sure that the number of matching parentheses, the number of closing parentheses matches the number of. Thus, an initial thoughts may be to ensure that there are enough unlocked slots to balance the number of parentheses. However, this encounters some problems. A locked can only be matched to a yeah that comes after it. That comes before it, yeah. 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 Yes. Oh, Fifi, come do a prayer. Precious. Because of this, as long as any locked right or left parentheses are matched up, the remaining unlocked slots are guaranteed to have valid solution approach. So, uh, we will take a greedy approach. We'll try two main questions. How do we deal with locked parenthesis like this? How do we deal with locked parenthesis like this? Ideally, we pair up as many locked sets of parentheses as possible. This allows us to use um, unlocked slots freely to pair with less locked parentheses. Uh, hmm. We can't match a locked using an unlocked slot. I still don't get it. Oh boy. You see, in cases like of extremely, almost okay. So here it is, right? The most important point here is knowing, when we have zero, this is locked. I mean, this is unlocked. It means we can swap, right? We can swap the value of the parentheses. But while we're swapping, we want to swap so that we get like a valid one. A valid parenthesis, like it states here, is a string like this, right? But how come this somehow is valid? Because when you look at this, right, when you look at this, the first one here, I don't want to do this. This is just really tedious to look at. But here and here is valid, here and here is valid. But now we have here, right? This is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. It means this value here we can swap. We'll swap it to this. This we leave it like that. These two here we also leave them. We don't really care. We also leave these two. Well, at this point here we have add a closing parenthesis, right? When we have a closing parenthesis, and the value is at where? Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It means we can also swap this. We can. How many? What really makes a valid parenthesis? What Let's go back to the drawing board. I really want to solve this question, and I will. I will solve it. Like, it's just so. What makes a valid parenthesis? A valid parenthesis is a value, a string that is like this, or a string that is like this. But in this case, why would this be valid? It's only in the case where here the locked value, the corresponding locked value is equal to. Let me just drag this down a little. The corresponding locked value at this point, right, is equal to 0, right? When it's 0, then we can change this to this, and this is also 0. That means we can also change this to this, and this will match, right? But if this is like this, if we had like 0 and 1, we can still change this to this, but then because this is locked already, we can't change this, and we'll have something like this. This is not valid. That is wrong. It isn't valid. So it means I at this point here always has to be 0, right? For us to know whether we want to swap or not, right? Um oh, it's still not coming. I think I might have to close now. I have something else to do. I'll come back to this question again. I will solve this question. I will solve this question in a very, 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 very clear manner. I know I have a feeling that I know the solution, but I'm just not getting that particular. Anyway, I'll continue tomorrow. But for next week, I'll be starting with a different kind of data structure. So let me come here. I've done arrays, string, and stacks. So next would be the next on my list would be something like this. I'll just go to here. Um, you know what? Because I did not solve, let me just try and solve another question. I won't just close without solving any other question. There's this question I saw before, and I might have solved it once, but I don't remember how I did it. It's usually like that, right? So let me just go back. There's I've solved valid parentheses before, right? I've solved valid parentheses. I just have a bunch of questions here. Evaluate reverse Polish notation. You know what? Let me solve this one. Okay, wait. Valid parenthesis. Yeah, this is what I did the other day, right? So this is quite easy. Valid parenthesis. Good. It's a good question. So the step is to just add a parenthesis of a particular type to the stack, and then pop it off the stack anytime you find a valid pair, right? So here's it. So what I did is I looped through the string, right? The original string will be given, and each time I add an item to the stack. So when I add an item to the stack, I need to pop it with the corresponding item. So here we'll add this to the stack, and the next item here is this, right? So we remove this from the stack. We add this to the stack, we remove with the corresponding closing bracket and so on. But when we add to the stack and this is not the same as this, then we return false. It is quite easy. It's just like 10 lines of code, right? Yeah. But let's see. Minimum stack. And I also solved this already. Yeah, I solved this yesterday. Min stack. I solved min stack yesterday. All right, let me read this one and see if I can solve this one as well. So you are given an array of strings, tokens, that represents an arithmetic expression in a reverse Polish notation. Evaluate the expression, return an integer that represents the value of the expression. Wait, let me see. Reverse Polish notation. Operational stack. Redirect here. Blah blah blah. Reverse Polish notation, RPN, also known as reverse. Okay, I can't pronounce this, but yeah, notation. Polish. Oh, not Polish. It's Polish. Polish notation. Reverse Polish notation. I am so sorry. that. I didn't get that right. In reverse Polish notation, operation for. Oh, I already saw this question before. I did, but okay, okay, okay. So reverse Polish notation is when so here in reverse Polish notation, operators follow their operands. I think I saw this question before. I think on Geeks for Greek. I mean Geeks for Greek. But at the end of the day, oh no 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 no, this is not the same. That was an infix and a postfix notation. And oh god, good, 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 good. Output is 9. So 2 plus 1. Right. So the valid operators are these ones here, which is okay. Each operand may be an integer or another expression. Or another expression. Okay. Division between two integers always truncates towards 0. So we round up towards 0. We don't want decimal places. There will be no there will be there will not be any division by 0. Okay, that's kind. um the input represents a valid arithmetic expression in a very Polish notation, in a reverse. Okay, the input represents a valid arithmetic expression in a reverse Polish notation. The answer and all intermediate calculation are represented in a 32-bit integer. This again. So we'll be giving a token of strings, right? In a that represents an arithmetic expression in a reverse Polish notation. A reverse Polish notation. And we know that a reverse Polish notation is such that the operators, right, follow their operands. For example, 3 added to 4 will look like this: 3, 4, and then plus. Interesting. So what do we do here? Right, we have this 2, 1, and plus, right? 2, 1 plus and 3 star, right? This will give you 2 plus 1 times 3. 2 plus 1 is 3 times 3 is um is 9. So the answer is 9. Let me see in this case, right? 3, we have 4, 4, 13, 5 divided and plus. So what do we do in this case? We have 3 operands before the operators. Well, is this going to be I don't know. Let's see. We have 3 and 5. 3 divided by 5 plus 4 is equal to 6. Why did I do this? So we use, okay, an operand has to appear between an operator has to appear between two operands. So here, this one group, and the following is this, and then we have this plus. So this is one group, right? So every time we see an operator, we want to add it to 2 operands. Okay, that makes sense. That means if we added every if we had an operand stack and we added every item into that stack, then we want to, when we encounter an operator, right, we want to take every item in the stack, just two, the first two, so the topmost ones, right? The top one. So we want to do 5 and then 3, right? But we want to do the first before the second. So the first, then the operator, and the second, right? Then we get a value here, but we encounter another operand here. So we do that as well. We put the first before the second. Yeah, that work, that work, that work. So here we just do 10, 6, 9, 3, right? But we see a plus here, so we'll do 3 plus, 9 plus 3, right? First, 9 plus 3 first, and then we see negative 11, so we just keep this into our print stack, right? 10 plus 11, and then we see a star, right? Right, multiplication. So we do this negative times, the previous, the whatever this gives us, we'll multiply it by this, right? And then there's another division, so the value of this, so 10 divided by whatever this value is, and the answer, right? So we now have another operator here. We At this point we have a single value, so we can directly multiply it by the next one, so this value here by this next one here. But then we have another value here, so we can add this to this, and then this value here plus what's, there's nothing in front, so we just do everything plus this. We'll ignore whatever is after. Right, I think that's like a brute force solution, but I'm just going to go through um and explain how we do it. I'm not going to write the code now. I'm running out of time already. I'm running really out of time. So yeah, let me go ahead and do like a brute force solution. And I'll also solve this some other time too, but not today. I'm quite late. Um, I'll use this expression here. I'll use the most difficult one, and uh, let me start with the. Okay, let me use an easier one first, and that will help me create a better foundation for the difficult ones. Okay, so we have something like this, and here. Oh, all right. So I said I'll create a stack for my operators and operands. So operands here. I'll call this operands, and another stack for my operators. Operators op. I'll just call this R. I don't know why. So here I have two, right? I'll add two to my stack. Is one, I add one to this stack here, right? Now I have plus, right? A plus. I don't need a stack for the operators at this point. In this case, at least, I don't need a stack for this. So I have 2 and 1, right? So I need to start looping from the top of from the last item. I want the first two items in my stack, basically, because the operand works for two items at a time. So here's what I'm going to do. The operator works for two operands. So I'm just going to take the previous two items, right? So I'll just do the last one will be, so I'll start from 2 downwards, right? So I'll go like this. I don't want to do 1 plus 2, right? I don't want to go from top to bottom. I want to go from bottom to the top. So I'll just do 2 plus 1, right? This will give me 3. So now the item at the top of my stack now will be what? Will be 3. So here will be replaced with 3. So I have 3 at the top of my stack. The next item I have here is 3. I add 3 at the top of the stack. And the next item I have is an operator, right? So this is here. So what I will do is to just take the first two items. So 3 star 3, right? And this will give me what? This will give me 9. And that's it. That's like the simplest way to do it. But when it becomes complicated, right? Does this method still work? Does it work like this? So I'll just come here. I'll use these tokens again. I'll replace these ones. I'm not going to replace them. Nah, let me replace let me replace them by these ones here. Okay, so I'm just going to use my old solution again, and I'll see if this works truly. If it does work, then it means this is right, and I'm sure there will be, some edge cases somewhere in this implementation. I mean, given the fact I'm using the same solution, the fact that I'm using the same solution, the same approach. Okay, so here's my stack for my operand stack is equal to this. Then so I add 10. I have 6, right? The next one is 9. I just keep adding the operands, right? 3, right? We're at this point 3, but now we have a plus, right? We have a plus. So what do we do where we have a plus? We'll evaluate the last two, right? Starting from so we want to take 2, right? So we'll go from 9 to 3. So we'll do 9 plus 3, right? 9 plus 3, this will give us 12, and then we will replace this here, the first 2 here, with 12. So I'll just change the color. Let me erase this. So I'll add 12 now. 12 will be at the top of my stack. So I'll go like this, 12. So the next item we have is negative 11. So we add negative 11 there. But now we have a multiplication sign. So a multiplication sign, we will do the operation again. We'll take again the last 2. So 12 times negative 11, right? We'll do this again. So I'll just let me use this will give us 133, but let's just verify that. 11 times 12. Okay, so 132, not 133. So 132, right? This is equal to 132 and negative 132. I will still replace this with negative 132. I'm just going with the flow. So I have negative 132 here, and the next time I see another operator, which is a division operator, so I take the last 2 items. Now I'll take negative 6. I'll take 6 divided by negative 132, like this. And what will be the answer? So I'll say let me just divide this. Let me just clear. I'll say 6 divided by negative 132, negative 132. Christ, this calculator is not what I expected. It's not doing what. You know what? Let me just use a different calculator. I think I have a calculator here. Yeah. So here's what going to do, I'll say 6 divided by negative 132, right? This will give us negative 0.04, but we want the nearest, you know, the nearest, um, how do you call it? The nearest number to 0, right? So we just mm, convert it to 0. This is negative 0.045, but we don't want this, right? So the question is, so we just make it negative 0, right? So we replace these two here by negative 0. So we replace this two here by negative 0. I'll use my eraser and let me just erase these two. I'll put negative 0 here, negative 0 there. Now we have a multiplication sign now. Interesting. So what do? We multiply the last two items in the stack. So I'll just do negative. I'll start from the last one, right? So we start 10 times negative 0, right? 10 times negative 0. Of course, this will give us negative 0 again. So we replace this by negative 0, right? So let's just, I mean, this is not going to be negative 0. So negative 0 is still 0. Sorry. So here we have 0, right? So let's replace this by 0. So we have this is equal to 0. Now 0 is the only item we have in our stack now. So here we are at 17, right? So we add 17 to our stack, and the next item is a plus. So what do we do to a plus? We add the two items. So we do, I'll just put it here, right? I'm out of space already. Oh, let me just scroll a bit. Yeah. So we do 0 plus 17, right? 0 plus 17, this will give us 17. So we replace this by 17. So let's go and replace by 17. So we have 17. And then the next time we have a 5, and then we have a plus. So we have 5 here, and then we are here plus. So we find another operand. Again, we take the first 2. So we do 17 plus 5. This will give us 22. And is that our answer? Yes, 22 is our answer, and that is how we solve this question. Yeah. So I think tomorrow I would I'll provide the code for that. I've already done 2 hours 30 minutes, which is a lot. Yeah. Also it's a weekend, so but I still have a lot of things to do. Right. Thanks for watching, and for those who stayed throughout the stream, thank you for watching as well. And I'll see you guys tomorrow. I'm going to continue. Like I said, my plan for next week would be to start with a different data structure, which will be. Um, I'm going to continue with another one. It is, what's this? What did I plan? What did I plan for next week? Uh, okay, so I did stack already. I would do queues. Forget about the days. This is not really my original plan, but yeah, I'll share my plan in the, yeah. So it's going to be queues and double pointers, all of that. I'll redo the planning again, and yeah, that's about it. And thank you for watching. I will see you tomorrow.